Our next lesson is on geometric series. So if you think back again, we did arithmetic. The difference between arithmetic and geometric was arithmetic was adding, subtracting. Geometrics was times or dividing. And when we did a series, that was the list of numbers. And then our sequence was a list of numbers. And a series was the actual sum or subtraction of them. So the same thing applies here. We're looking at sequences that multiply or divide. And now we're looking at adding everything up. So this is a picture where would be you got one person, you're going to tell three people, so you'd have three more, and then the next one they're each going to tell three, so that'd be 9, so we'd have 1, 3, 9, they're going to tell three more, so we get 27. So the question would be how many people know, so in this case we'd have 1 plus 3 plus 9 plus 27 would be our geometric series. So same sort of logic applies, just we're dealing with geometric, so we have a different formula once again. So our geometric series is the sum of terms, just like it was for arithmetic. So if we have a sequence like 6, 12, 24, 48, if we add them all together, that'll be our series. And our formula that we use is looks a little more complicated, but it's pretty simple. Just plug your numbers in. So we have term 1 again, and we need to know our R value, what we're multiplying by, and how many terms. And it just sort of depends on which way we want to use it. Quite often, if our R value is a fraction, so if we're dividing, so that's where R would be like a half or something like that, we use that formula, and we could reverse it, so we can have R to the n minus 1 and R minus 1. It works the same, but that one typically works well when you're multiplying, because then the R value is bigger. But either one works as well as the other, so it really makes no difference. So let's go through an example. So this one's saying, find the sum of the first 15 terms. If we go back to our formula, we need to know our R, we need to know the number of terms, we need to know term 1. So we're good. So if we look at this one, we can see we're dividing. So let's use our first formula. So it was T1, 1 minus R to the n, divided by 1 minus R. So we can plug this in. We want the first 15 terms, so term 1 is 40. Our R is, we're dividing by 2, so we'll write that as a half. And we want 15 terms, so it'll be half to the 15 divided by 1 minus a half. So it's a little bit more complicated to calculate, but just use your calculator. So if you go 40 times brackets 1 minus 0.5 to the 15, that'll give you a really small decimal, and divide that by 1 minus half, which would be 0.5, we get 79.9997, and so on. It's going to be a repeating decimal, so we'll just round this off to 80. Okay, so we can kind of see that it's going to be, as we get smaller and smaller, we keep dividing by 2, we're going to get really small decimals, so they're really not going to do that much. Okay, so that's the first part. So you want to be careful, just be careful of your signs and so on, and everything works out pretty good. Actually, I think we messed up this one. Yeah, sorry, in the formula it's 1 minus R, and in this case our R was negative a half, so we actually have to do the negative half separately. That might make a difference, and I think it will in this case. So let's do the 1 minus brackets, negative 0.5 to the power 15. Times that by 40, and then we want to divide it by 1 minus negative a half again, which will actually now be 1.5, so that changes things a little bit, and it is. So our answer was wrong. That would be if it was going 40, 20, 10, 5, and so on. Because it's the negatives, we actually get a smaller total. So we actually get 26.667, and we could leave it like that, or we could even round it off to a fraction, like 26 2/3, 26.7. It doesn't really matter how we round these off. And that makes more sense, because if you look at it now, we got 40 minus 20 is 20, plus 10 would be 30, minus 5 would be 25. So you can see we should be an answer closer to what we just put here. Okay, so here's another one. Sum of the first 10 terms is 29, 524. Common ratio is negative 3. So we use the same formula again, but we're looking for term 1 this time. So we'll be careful this time of our negatives. So they tell us our sum is negative 29,524. term 1 is what we're looking for. We'd have 1 minus negative 3. Actually, in this case, it's getting bigger. So let's use our second formula. What it does is it avoids negatives. So it's just written the other way around. So it'd be r to the n minus 1 and then r minus 1. So in this case, we'd have negative 3 to the 10. So we want to make sure we put that in brackets. Minus 1, and then on the bottom we'd have negative 3 minus 1. So let's simplify everything that we can on the right-hand side. So we end up with term 1 times. So let's go negative 3 to the power of 10 minus 1. And we want to divide that by negative 3 minus 1, which would be negative 4. And that gives us negative 14,762. So if we divide that from 29,524, we end up getting 2. So in this case, term 1 is 2. So that's pretty good. So it'd go 2 to negative 6 to positive 15 to positive 4, negative 45 to positive, and so on. So we just keep multiplying, and it should work out. Okay, here's another one. We want to know the total sum from 6 to 1228. So let's use our new formula again, where we have, since we're getting bigger, we'll put in the r to the n minus 1 over r minus 1 like that. So you can see we have our term 1 is 6. We know our r is 2 in this case. We're timesing by 2 each time, but we don't know the number of terms. So we did this previously. We have to do our t of n formula first to figure out what our number of terms are. So let's plug that in first. We got 12,288. Term 1 is 6. Our r was 2 to the n minus 1. So we want to divide by 6. So 12,288 divided by 6 gives us 2048. And once again, we'll sort of guess and check. So 2 to the 6 we'll try. It's too small. Let's try 2 to the 8. It's too small. 2 to the 10. It's too small. 2 to the 11 is 2048. So 2 to the 11. So that means n has to be 12. So now that we know that, we can go back to our formula, and we can actually calculate the sum. So our total sum would be term 1, which is 6. R was 2, n is 12, and that's it. So all we have to do is go 2 to the 12 minus 1 times it by 6 and divide it by 1, which doesn't do anything. So in this case, our total sum would be 24,570. And let's do one more question. So this one's a word problem one. So it's saying we have antibiotics. It says you start at 200 milligrams and you dissolve 12% of its size by the time you take the next pill. Okay, so same sort of question, but what we're looking for is we want the total sum. So we have a T1 of 200. Our R, it says we drop down to 12%, so it'd be 0.12. And so we want to figure out what it's going to be after we take 3. How much is totally in your system? So the first one we want to do is figure out when n is 3, and then we want to figure out when n is 12. And we want the total, so we want to use the S of n formula. And because our R is 0.12, we're getting smaller, so let's use the reverse version. So go 1 minus R to the n. Okay, so on our formula, we'd have 200 times 1 minus 0.12 to the 3, and 1 minus 0.12 will be our bottom number, so we can plug all that in. So let's do the brackets first. So 1 minus 0.12 cubed times 200 divided by brackets 1 minus 0.12. And that gives us 226.88. So if our original was 200 milligrams, after we take 3 pills, we only have 226. So that third pill adds the 200. So we didn't really gain that much. So let's try it with 12. We should see we get similar kind of numbers. So we'd have 200 again, 1 minus 0.12 to the 12, and we're going to divide that by 1 minus 0.12 again. So our total sum in this case, so 1 minus 0.12 to the 12, times 200 divided by 1 minus 0.12. So we only get 227.27 approximately milligrams. So you can see each time you take a pill, by the time you get one, there's not that much left in your system. So it only stays around 26, 27 milligrams as extra. And that's all for this topic.